Welcome, my name is Brian Thomas, and I am going to do a quick demonstration, a fairly quick demonstration of the Fairchild PSWeb tool for you today. So in order to get to the Fairchild PSWeb tools, there's a couple of ways that you can get into the tool. One is directly from Fairchild Semi, and Fairchild has a nice link to it on their front page, which is here. An alternative way to get to it is directly from Arrow. From the Arrow website, you can go to Arrow, click on Electronic Components, and then you scroll down and you get to Online Design Solutions here. And you get to the Transcend Design Web, which basically gives you an overview of all the tools. I'm going to select by company, which gives you an overview of all the companies that we currently have tools for, and this is an expanding list. I'm going to go directly to Fairchild, and what we're going to cover today is the PSW tool, which is the Power Supply Web Designer. In order to start that one, I can click this link here, but I'm going to go back to the Fairchild tool and give you an overview of how the Fairchild link does, because the way the registration works on Fairchild, they actually give a nice introductory primer on this one that'll teach you a little bit about how to use the tool. And so if you look here, there is a nice web page that basically gives a complete overview of the tool, the different steps, some nice little tool tips. So if you want to refer to this one, you can. I'll be covering a good portion of this during the tool overview, but this is a nice little tool primer for that one. And then once you're in here, you should just click Power Supply Web Designer. And right now you can see it's loading, and it's going to ask me to log in. And since I already have an account, my name shows up here. If I'm not registered, then you will have to create a registration with Fairchild Semiconductor. It's very easy registration process, and once you're registered, then you can log in directly from the registration page here. And it takes you to the main Power Supply Web Designer page. On this page, there are actually two separate tools. One is the primary side regulated flyback converter, and the other is the secondary side regulated flyback converter. You know, how you select between these tools depends upon a fair number of requirements. Today I'm going to actually focus on the secondary side regulated converter. The primary side is basically a simpler controller. The secondary side has a lot more capability. It will do up to 3 outputs, whereas the primary side will only do a single output. So today I am going to focus on the secondary side controller. So as you can see, when I hover my mouse between these two, it highlights one of these. If I just click on one of these, it allows me to go into the design. Now, if I look at this one, I am now in the design steps for the tool. And there's a few key items to notice about this page. So basically, you'll see an autocomplete button, you'll see a next button, and then a reset button. And what happens with each one of these is if I want to take the defaults at any time during the design process through any of these steps, I can hit autocomplete, and it will speed through all of these steps and create a design. For the purposes of this demo, I'm going to actually go step by step so you can see some of the key items about this one. In order to do the design, I have a series of different steps that I have to go through. I have to select my input requirements, I have to select my output requirements. I have some other inputs that I can apply here, and if you just click on the plus and minus, you can see those different ones, and of course it'll scroll down your web page so you can see what you're inputting there. In this column is the actual design value. So when you input something into this box, that is the design values you are going to use. There is another feature about this one that actually spits out a recommended design value, which is this area in the light. It's a very light blue. You may not be able to see it in the video, but I can always override that recommended value and select a different value when I input it. It will ask me, do I want to change this one? And if I accept it, it will now recalculate all subsequent values based on the change that I made here. And so right now it's doing all of the math on this. And you can see I've changed a simple value here. If I ever want to reset that one, all I can do is click on this box, and it will load the new values and recalculate based on that one. If I ever get myself into a complete jam, I can always hit this reset button, and it'll reset everything to the default value and take you back to the beginning steps. So let's go through a design here. I'm going to do a more complex. I'm going to do a 3 output design. So if I click this one, you'll see now that it allows me to select up to 3 different outputs here. I can change the output voltage, the output current, any of the requirements for each one of these outputs. For the sake of simplicity, I'm going to stick with the default values at this time and just go through this one. I'm not going to change any of the values as we go through, but you feel free to do it if you wish. If I were to complete autocomplete now, for example, if I hit autocomplete, it will go through and automatically do all of the subsequent steps with default values and generate the design, and it will take you straight to the analysis page. And if we give it a second here, right, which will take you to the schematic where you can do the analysis. The schematic will pop up here in a second. If I don't want to do that, I really want to go back and specify the details of this one. I can either click on a tab here, or I can click the next button. And another key item about this one, you'll notice all these little question marks here. Each one of these question marks will give you details about what is happening in each one of these. It'll give you descriptions about what that parameter is and how, what changing that one or how that's going to affect your power supply design. Very detailed help all the way through this one. Again, I'm going to stick with the basics on this one. I don't have to expand these to look at them, but in each case I have basically details of all of the steps needed to generate this design. Go to the next one. Let's say I get to this page and I realize, hey, I don't want to stick here. I can always hit back, and it'll take me back to the previous step, and I can select a different one. So let's say I don't want to use this part. I want to use one that has a slightly higher output. I'm going to select that, and it will change all of the subsequent steps below that one so that the power supply design is based around this part as opposed to this part. So I'm going to hit next, and now I'm able to start to design my transformer for this one. So I have multiple steps for the transformer. I picked a part that can do a slightly higher output power, and so I'm going to actually adjust my core so that I get a basically higher power part as well. So I'm going to pick one that has basically a higher efficiency part. So I'm going to pick one that has a slightly better AE to AW number. And now it's going to select that core. I can change my bobbin selections, but it basically automatically sets that one up. My turns are automatically calculated for my design. My gap is set up for that design as well. And then, of course, I have my windings page, which basically shows all of the different steps in designing your transformer. It's a very detailed transformer design for each of the items. It will have some help graphic here, and also there will be help buttons here that you can actually click on and get details about them as well. And I'm going to go all the way through these steps and step through them. And let's say I don't want to go, I'm going to go ahead and step through them. So I have my output filters. One of the things I want to put on here is my control. And I'm going to put some snubbers in here. In this case, right now, just for demonstration purposes, I'm going to put some secondary snubbers on these. So basically, you'll notice when I check that one, it gives me more parameters that I can input. I'm going to use the defaults for each of those. And you can see now I've added a snubber across the diodes on the output. And I am going to leave that for now. And now I get to an efficiency page, which basically gives me a summary of all the efficiencies for the part. So it gives me my different efficiencies, and then I can either click next. In this case, I'm going to click autocomplete because it's basically the same as next because I've run out of steps here. And I get to a page that shows me my design schematic. This is actually a pretty large schematic, but you can see here that my snubbers have been put into the design here. If I were to go back to the design analysis, just as for demonstration purposes, let's say I decided I don't want to put those snubbers in there. I just have to go back to the snubbers, tell it not to put them in. So I'm going to leave it on the primary output. And I'm going to take it off the second and third output. So now if I autocomplete, you'll see that those two snubbers have disappeared from my circuit. So you can see here I've managed to take those two snubbers off the circuit. Once you're on the schematic, you can change any of the component values here by clicking on the component and change it to a different value. We recommend that changing components is something that an advanced user would want to do. When we spit out a design through the tool, because we've gone through that full design process, all of these components are selected for a good design. When you start to change the components here, you are now starting to alter the design, and you may get yourself into a design that may not work and may not simulate well. So I'm going to choose not to change them. You can always go back and change via the design tab, but if you want to change components, you're able to do that directly on the component values. So for example, I know I can change the capacitance. Let's say I want more capacitance on this one to make it 100 microfarad. I can change that one. And you'll see that that has changed to 100 microfarads here. Now, this is the design schematic for this power supply. And this power supply, it has the input filters, it has all of the output components in there. And you'll notice that it's set up, basically, it's set up for an AC input because it has the bridge here. When we actually simulate this one of the things done in the modeling process was to simplify that design schematic so that it will run much, much faster when you go to simulate it. So a lot of the extraneous components that are there for basically to make an EMI compliant design have been moved out of this simulation schematic so that you're only simulating the basics of this power supply. So you're simulating the chip, the transformer, but a lot of the extraneous components for like protections and things like that have been removed to make the simulation run much faster. So for example, if I run a transient analysis, you can see it's going to take about 12 seconds. This simulation timer is an estimate, and in some cases it's fast, some cases it's slower. It's really an estimated time remaining based on the number of designs that have been run. Since I picked a 3 output, it's going to run slightly longer, but we'll see that it's going to pop up and give me some results here in a second. There we go. And so now we've got results for this one. And when I click results, I go into the web scope, and the web scope will give you the simulation results for this one. In this case, I can see the results for output 1, I can see the results for output 2, I can see the results for output 3, I can actually look at my control signals, and I can look at the powertrain. Now, there's quite a bit of information here in the web scope that I need to kind of walk through and give you a feel for what happens in this one. You can see here I have quite a few waveforms in the powertrain. So I have the drain current, I have the drain voltages, I have the input current, I have VN, and I have VP, which should be the primary. If I shrink this down, I can look at the schematic and see what VP. VP is simply this probe right here, which is the voltage, across the primary winding. I don't necessarily want to look at all of those. I can just remove all of them and pick the ones that I'm interested in, or I can check them all and uncheck the ones that I'm not interested in. So if I just want to look at V drain and I drain, I can look at those. Now you'll notice that this is quite a number of switching cycles here. It's showing the powertrain. I can actually take my mouse and zoom in on a portion of this. And so you can see here, by zooming in, I can get closer and closer to these waveforms. And I can actually zoom in pretty quickly and get quite a bit of detail. That shows how I can actually zoom in and zoom out of the different waveforms. There's a couple of other features in this tool. For example, I have these 2 little cursors that I can drag over. So I can actually come in here and measure between this point and this point, and I can see that between these 2 markers, I have a delta time of 14 microseconds. So it's 10 to the minus 3. If I switch this over, I can actually get the frequency, which is right at 67 kilohertz. And that shows me the delta time between those 2 markers, so I can see where those markers are. If I were to expand this out, again, that's going to give me my delta time between those 2 points. It's very convenient for actually measuring frequencies when you have a switching waveform. There are measurement functions built into this one, so there's a whole host of measurements that I can get on the tool. If I click RMS, it's going to give me the RMS of all the data for I drain. So here I can see I've got 530 milliamps for I drain. But I can also look at the RMS value between the 2 cursors, and between these 2 cursors, the RMS value is now 557 milliamps. If I were to move these 2 cursors here, you can see that the drain current, which is the blue value, is now much, much smaller because I'm centering around 0. If I were to focus on the areas between here and here, and since I'm really struggling to get to that, I'm going to zoom in on that area. So here I can look at the drain current, and you can see by changing between these 2 values, I can easily pick that one. I have full measurement capability for each of these. I can do averages, I can do maxes, I can do peak to peak, I can actually look at the slope between the two cursors. So quite a bit of measurement techniques. And you'll notice that when I was on this tool, I was zooming into the waveforms. If I ever need to get back to a different zoom level, I can go back one zoom level, which takes me back to where I was at, or I can reset the zoom level to the basic default value that came up when the part came available. I can also take my hand and drag the waveforms around. I can zoom in by clicking just zoom in. I prefer the drag method to focus in on what I want, but you can feel free to do whatever. There is one more feature that I do want to show you on this waveform viewer. You'll notice here that the drain current is on top and the drain voltage is under it, and it's somewhat hidden because of the number of blue waveforms. If I click on the drain current, I can move that up, and you can see that brings that to the top of the pile, and so my drain voltage is actually the one that's on the top. If I push it down, it's gonna put this waveform on top, this waveform next, this waveform next, this waveform next, this waveform next. So there's quite a bit of capabilities in the waveform viewer. And of course I can run the different analysis. I probably should have done this all along. And I will run steady state as well while we're waiting here. And each one of these I can click on to pull up the waveforms, or I can actually click on this window and I get a summary of all the different waveforms that I have. And so, for example, if I click on this, that takes us back to the transients information that we were looking at. I have AC analysis, which allows me to do gain and phase margin, so I can actually go in here and click and see, based on my gain, what my phase is. And here you can see my cursor is here at 49. So basically when my gain crosses 0, I have 49 degrees of phase margin. Now, also I have steady state results, which is basically centered on switching cycles. The simulator behind this is Simplest, which is a piecewise linear simulator, which is geared specifically for rapidly changing switching waveforms. Unlike a SPICE, which is a time domain and simulates on a step-by-step basis, the piecewise linear actually looks at the linear equations and finds solutions to that one. So it's not so concerned about the switching events, and which is why it can run these simulations much faster than, say, a SPICE simulator, because it's solving the linear equations for each of the states, as opposed to taking a time step and then trying to converge, which is why Simplest is such a good tool for switching waveforms. So I've got my design done. I'm pretty happy. I've looked at my waveforms. I think I'm pretty happy with them. Now I'm ready to go and buy parts for this one. I have a BOM tab, which will pull up the BOM for this tool, and it's going to load here real quick. And so what I get is a list of components that have been predetermined based on a set of rules set up by the applications engineers. And I have a full list of ones. And what I'm using here is a generic BOM, which has a large number of parts in it, including parts that are in the Arrow database. So you'll notice if I use Arrow as the distributor, I'm now getting the components that are selected specifically from the Arrow database. And so by using the Arrow database, in a second I should see the Arrow stock prices and availability. There we go. My little swirly button is showing me that I'm now connecting directly to Arrow, and I'm getting availability of parts and pricing for this BOM. I'm going to go back to generic here real quick. And let's say that I don't want to use a specific component in here. So let's say I'm looking through this design, and let's pick a component here. Let's say for my output capacitors, my 0.1 microfarad output capacitors, I don't want to use AVX. I'm not a big fan of AVX. I'm not saying that I really mean that one, but let's say I have a supplier that I have a buyer that doesn't want to use AVX, or I have a preferred vendor. Let's say I want to use Kemet. So if I change my filters, I can select to only pick components from Kemet. So right now, the rules that the application engineer has set up are basically these rules. So he said he's looking for components that are between 100 to 150 nanofarads, and that will change based on your design parameters. Because of my design requires a voltage greater than 24 volts. I want to focus on 0603s and 0805s, and I'm going to pick capacitors based out of this material, and of course I want to be RoHS compliant. But I don't want to use AVX. I want to use only Kemet because they've been really nice to me, and I'm gonna just use the Kemet component. So if I apply filters, now what I've done is I've narrowed my selection to just the Kemet suppliers. And you remember here originally I had the AVX component. So now I can go through this BOM and say, okay, which one do I want to use? And I'm going to use this component. But before I do that, I want to do a quick check of it. I don't have a data sheet for that one. Sorry about that. Let's try a quick check of one of these components. Let's go down to, let's see. Let's try one of these. If I click on one of these components, I can actually get to the data sheet for the component when it's available and get more information about that part. But again, I'm going to go for one of these cut tape parts because I know availability is usually better on the cut tape parts and for small designs. And so I'm going to select that one, and you can see that it has now applied that one to this component. I changed my mind. I don't want to use that one. I can always reset my filters to the defaults, and it takes away that manufacturer. Let's say I really, really don't want to use any of these rules. I can actually clear all the rules and then go in and set up my own set of rules. So I can actually come in here, and I know I want something I want around 100 nanofarads, so I can slide my sliders so that I get something close to 100 nanofarads. And I can adjust those. My voltage rating, I know, had to be greater than 24 volts, but let's say I'm not happy with that margin. I want to go with something bigger. I can go 53 volts. I have a whole list of different components that I can go to. I prefer 805s for this design, so I'm going to pick the 805 components. And this number shows me how many I have available, so I'm going to select the one that has the most available. And I know that I only want to use X7R for this design, so I'm going to pick the X7R components. And if I apply the filters, now I have a list of parts that are specific to mine, and I'm going to use this TDK part. So I'm going to click on that, and you can see now that one's been applied to the BOM. Fairchild uses a host of different distributors. They have Arrow, they have DigiKey, they have Mouser, they have Avnet, they have Future. So when I switch between distributors, I get only components that are available from that distributor. And it will load the components available there. And it will go off and look at what's in stock and what's available. But now I'm done with my design. I really just want to go back to my generic. Of course, I have the ability to download the BOM directly from this page. If I click on this one, I will get an Excel spreadsheet that has the BOM in it. And unfortunately, I don't have Excel loaded, so I'm not able to actually open it. So I can save the file, and I'll have the BOM. I don't think it's going to let me open it. Well, maybe it will. Clearly some open source software on this machine. And sure enough, it does open it as an Excel file, and you can actually see the components. You probably don't see that. There we go. Let me share it. So now you can see the Excel file that has the parts in it. So it gives me the part numbers, the manufacturers that were used in that design. I'm going to stop sharing that. Close that. We don't want to see this anymore. Now that I'm done with my design, I want to generate a report for this one. So I have a summary page that has all of the design requirements that were used for this design, and it's a large number of variables in here. I get all of the graphs that I generated in the tool through the different steps. I get my efficiency summaries, and I have my loss summaries in pie charts. I get the schematic that I used in the design. I've got my bill of materials, and then I have my simulation results. And one thing you'll notice on the summary page, I can always click on that, and it will open it up in the waveform viewer, should you want to look at it there. But now that I have the design, there is one more thing I might want to do. I can print this out directly using the web browser print capability. So if I were to print here, I could do a print preview, see what that's going to look like as a print of a web page. And let's close that. Or should I just want to save this on my computer as a file, I can always save this one as a PDF. You'll see here it's now going to load this one up in Acrobat Reader. And if I can open it in Acrobat Reader, and you can see my report. I need to go into WebEx and share that with you. A moment. Go share application, Adobe Reader. There you go. And you should be able to see the PDF that I generated here. And so right here I get a full file that has all of the inputs. You can save this on your PC by just clicking on the file save, or you can print it out directly from here. But again, this has all of your results and the waveforms in it. So it's a nice report that you can either give to someone that you're working with on it, or as a report to show, hey, this design should meet your requirements. Now that I have this design done, there's a couple of other things that I can do to it. I have the capability to do a save and a share of this design. So first things first, I'm going to save this design, and I'm going to save it as Arrow Demo. And video, and I'm going to give it a slight comment. So when I save this design, you'll notice that the name changed here to Aero Demo, and so that tells me that that design has been saved, and it's now part of my designs. So I can look, now that I've saved that one, I can always go back and open it, or I can open any one of the other saved designs that I have created in the past. But go back. There is one other really nice feature that I can do with this one. I have the capability of sharing this, and I can share this with anybody who I happen to have their email of. And so I can invite a new user to basically log on to the tool, or I can just share by design. Hang on, let me back up here. Let me go back to share. So what I'm going to do right now is I'm just going to send an invite to one of the other employees here at Transem to become one of my shared resources. So I'm going to send it to LBER.com, and I am going to send him an invite. Now I can let him read this design, or I can give him full control of it to read and write. So I'm going to send him an invite. You should invite them. So first things first, I need to invite the user. I'm going to invite him. So now this will send an invite to Trevor, and he will get an email that says, hey, here's this invite. Click on the link, and it will take him directly to the design that I shared with him. Now, there's a couple of other features. Since I have multiple designs here, unfortunately I don't have anybody that has accepted my shared request. But I can pick a number of designs, and since it's saying I have no contents, I can't demonstrate that I'm going to share by contact. In another tool, we have some other tools where I can show you that. I'm going to do another demo later for on, but I can show you that. But if Trevor were to accept my invite, then I should be able to share that one directly with him. I also have a log of all activity to the different designs. So I have capability to actually look through the log activity for the different designs, and you can see here that I created Aero Demo at 10:12 a.m. If I were to go back and change this design and resave it, that activity log would update. And again, if I ever want to open a different design, I can always click on one of the saved designs that I have and open those as well. Now, there are a couple of other things that I do want to point out. Let's say you're in the tool and you run into an issue, or you think of something that might be useful. You can always go into the Give Feedback, and what this will do is allow you to send comments to the support site about you can give it general feedback. There's a whole list of topics here. You can do general feedback, you can do an application simulation issue, a feature request, a part request, or a support request. So I'm going to just give general feedback and say and I'm going to submit that feedback. And when I submit that feedback, it will submit it to the support site. And depending on the type of feedback, that will either go to, actually the feedback goes to both Fairchild and Transem. And if it's a simulation issue, the Fairchild guys, or if it's an application issue, the Fairchild guys will look at it and see if it's something they need to answer, or if it's an issue with the tool, it will come to Transom, and we will look at any bugs or issues that occur with that one. And that is a summary of the Fairchild tool. Feel free to actually go into the tool, play with it, create designs, run through the many things that you can do with the tool. I've only covered some of the brief items here. For example, if I went into PSWeb, I get a different tool that allows me to design around that one. So have fun with it. Use it with your customers. By all means, get them to go in and show them, maybe designs that you have that can support them. And always feel free to look at those help files on the Fairchild, because it does give you a good overview of the tool. That's all I have for you today. Thanks for viewing.